Now we're going to do a few problems where we're going to do kind of the opposite of finding the tangent line. Remember when we found the tangent line, we found the straight line which goes through a certain point on the curve, and it has the same slope or gradient as that point on the curve. Okay, now what about a normal line? A normal line is perpendicular to that line and goes through the same slope. So that green line would be the normal line, for example. It's perpendicular to the blue line. I tried to make it look perpendicular. And it goes through the exact same point. Now, the tangent line, remember, is really easy to find on the calculator. The normal line is not so easy, but we use the same functions we've been using to find the derivative and the tangent on the calculator. We're going to use that to almost find the normal line, because, of course, the normal line does not have a gradient that is derivative or tangent to the point, because it's exactly the opposite, right? It's perpendicular. But if we find the gradient of a tangent, then we can find the normal line just by finding the perpendicular. And do you remember how to find perpendiculars of a line? All you do, like if you have, like, say, a gradient of 2, to find the perpendicular to that, you would just take the negative inverse. So negative 1/2 would be the perpendicular. Okay? So first thing we're going to do is we are going to find the gradient. And we can find the gradient by using the dy dx function or the tangent function, whichever you prefer. After you find the gradient, then you find the negative inverse of the gradient, and that is going to be the gradient of your normal line. Okay? And then you use the gradient to find a second point on the line. Okay? Like, for example, they already tell you one point on the line. Let me show you an example problem. They're saying, show me a normal line that goes through this point. So you have one point. How do you find the second point of a line? You can use the gradient to find the second point on the line. Why do you want to find 2 points on the line instead of just using the point and the gradient? Well, because if you remember many months ago when we talked about linear equations, we can use the calculator's ln-reg function to easily find the equation for the line given 2 points on the line. So that's how we're going to do it. I'm going to show you how to do the first one. Hopefully you'll have a better idea about how it works. Okay, so the beginning is the same. You're going to take the function 2x squared, and you are going to put it in the calculator, and you're going to graph it. And it should be, yeah, it's just a parabola like we always do. Okay, so it's a parabola. And there's a point on here, 1, 2, where they want us to find the normal line, which passes through that point perpendicularly. So I'm going to show you the steps we're going to do to find that. So the first step we're going to do is we're going to find the tangent gradient through that point. And we use the dy dx function on the calculator, or we use the tangent function, and then we find the slope or the gradient of this point. Once we find the slope, then we can take the negative inverse of the slope, and then we will know the gradient or slope of the normal line. However, we only know the gradient. We don't know the equation of the line. How do we find the equation of the line? Well, we have one point on the line. We have this point, right? If we can find one more point on the line, then we can easily find the equation of the line using the ln-reg function. So how do we find one additional point, like, for example, this point or this point on the line? We can just make a sketch and use the gradient of the normal line to extrapolate one additional point. Okay? So, and then once we do that, then we can use ln-reg, and we can draw a line through those 2 points. Okay, many steps. Okay, so first we're going to find the gradient at x equals 1. So we could do that using dy dx or tangent. Let's see, that was to find dy dx, it's second calc. And we go to dy dx, which is 6. And then we go to 1.1, or x equals 1. And that tells me that the gradient at that point is 4. So we know that the gradient is 4. Okay, so for this here, we know that m equals 4. So this is for the tangent, or for the derivative. Now, for the normal, we take the negative inverse. So the normal slope is negative 1/4. Okay? Remember, negative 1/4 would be like negative 1 rise over 4 run, for example. Okay? So, and then if we start with the point 1, comma 2, let's draw a little graph here. So we have 1, comma 2 would look kind of like that, right? That would be the point 1, comma 2. Now we need to find a second point, which is on the slope negative 1 over 4. So let's say that the rise is negative 1. So we would say rise negative 1. Run is 4. So 1, 2, 3, 4. So rise is negative 1. Run is positive 4. Okay? So the second point we found is right here. And so the first point was 1, comma 4, 1, comma 2. This one is going to be, let's see, 1, 2, 3, 4, 5. 5, comma 1. Okay, and the first point, which was the point they gave us, is 1, comma 2. Right? Now we have 2 points, and we found the second point using the slope of the normal. Okay, and now let's use ln-reg, and this is something that you really need to be good at doing for the linear equation part of the exam. So I'm just going to clear out my list here. I'm going to use list 1 and 2, and I'm going to put the x's here. So the x's are going to be 1 and 5. And the y's are going to be 2 and 1. Okay, and then I'm going to use ln-reg, stat calc ln-reg 4, to find, okay, the frequency list can be nothing. Okay, so it's L1, L2 frequency list blank, and then I'll do calculate, and that'll give me this equation. So the equation is y equals negative 0.25 plus 2.25. Now the last step we need to do in this case would be to change the equation to standard form. So we need to put everything on the left and just leave, oops, there was an x there, and we leave 0 on the right. So we can add 0.25x to both sides, and we can subtract 2.25 from both sides. 5, and that gives us 0.25x plus y minus 2.55 equals 0. Okay? Whew, that was a lot of work for number 1, right? Now let's do number 5. Now, the good thing about the calculator finding the gradient and the derivative is you don't have to multiply that out. You could just enter that in just like that. So the first step, remember, is to enter the function in the calculator, and then we're going to find the gradient using the tangent function or dy dx. X plus 2, 5 minus x. Okay? And then graph it. And then we're going to find the gradient at point 0. So we'll do second calc gradient, point 0. It's going to be dy dx equals 3. So the slope of the gradient is 3. So you can see that our graph kind of looks like this. And basically we found that this point, the tangent line, has a gradient of 3. Now to find the normal gradient, the normal gradient is equal to negative 1 over m, so it's equal to negative 1/3. Now, and if we wanted to draw that, it looks like kind of like that, right? And now we know one of the points on the line. One of the points on the line is 0, 10. We need to know one more point on the line. Okay, we're going to find that second point by doing a sketch. 0, 10 is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 10. Okay? And our second point is going to be found using this slope. So remember, rise over run. So the rise is negative 1. The run is positive 3. So let's see. I would go rise is negative 1, so I go down 1. Run is positive 3, so I go over 3. 1, 2, 3. And then the second point would be right here, right? Okay, so our second point would be, let's see, it would be 1, 2, 3, 3, comma, and then 10, would be 9, right? Because this is 10, so the one below it would be 9. So we had one point at 0, 10, and we have one point at 3, 9. Now we're going to use lin reg, and we're going to find out the equation, the equation of the line that goes through both of these points. So we have 0, 10, and 3, 9. So we have our 2 points in here now, 0, 10, 3, 9. We use lin reg, which is stat calc lin reg number 4. And L1 and L2 are the x and y coordinates. Frequency list is blank, and then calculate. And so our equation of the normal line is going to be y equals negative 0.333 x plus 10. Okay, and actually negative 0.333 is like negative 1/3. Okay, now let's move everything over to the left side. So we're going to add 0.33x to both sides, and we're going to subtract 10 from both sides, and we're going to be left with 0 on the right. Okay, so we're going to add 0.333x, and we're going to subtract 10 to both sides. Okay, and that's why we end up with this expression here. Okay, so that is the standard form of the normal line, okay, to that curve. All right, now last one. We'll do this one here. So we program that in. It's going to be 6x plus 8 divided by x. So 6x plus 8 divided by x. I put parentheses here, but in this case, because of PEMDAS, you don't really need it. I'm going to graph it, and then I'm going to check what the gradient is at x equals 1. Now remember how I was doing this with the dy dx function. I can also do this using the tangent function. So why don't I do this one with the tangent function, just so that I'm doing zoom fit because it didn't show up last time. Now I'm going to see what is the tangent line at x equals 1. So I go, tangent line we do using second draw, then I go to 5, and then I go to 1. There it is. Okay, and it tells me that the tangent line equation is y equals negative 2x plus 16. which part of this tells us the gradient? The negative 2 does. Okay, so if I would have done dy dx at x equals 1, it would have given all me negative 2. But here I could just take it out of the mx plus c formula here. So negative 2 is the slope, right? So I could do it. I could have done it either way. Okay. So for number 9, the m is equal to negative 2. Okay. And of course, you could also take the derivative and then substitute in x equals 1. That would also give you the slope, right? And now what about the normal gradient? The normal gradient would be equal to negative 1 over m, which is equal to 1/2, right? Because it would be negative 1 over negative 2, which would be 1/2. Okay, so the normal gradient is 1/2. And we do know that one of the points we're looking for is 1, 14. So let's draw that in a sketch again. 1, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wow. Okay, 14. That line height there is 14. And then now I'm going to find the second point using a rise of 1 and a run of 2. Rise of 1, run of 2. So it's kind of like that slope, okay? So let's see, I'm going to use some fancy editing here and bring it down a little bit. Okay. And then I'll erase that. Okay, so now I'm going to use the pink pen, and then I'm going to draw this here. So I'm going to go up 1, and I'm going to go over 2. And that's going to be my next point. So the original point, remember, is 0, is it 1, 14? Is it 1, oh, it's 1, 14. So actually it's, the original point is here. Let me erase that. The original point is 1, 14. And then I use this slope to go up 1, and go up 1, and I'm going to go over 2. So if I go up 1 and over 2, I get this new point. The new point is up 1, so instead of 14, I'm going to have 15. And it's over 2, so instead of 1, I'm going to have 3. So 3, 15. So now I have 2 points. I have 1, 14, and I have 3, 15. I'm going to put both of these into stat edit, and then I'm going to use linreg to find what the equation of the normal line is. So 3, 15, and 1, 14. So 3, 15, and 1, 14. Graph it. I'm sorry, not graph. Stat, calc, linreg, L1, L2, frequency list blank, calculate. And that gives us y equals 0.5x plus 13.5. And if I want to put this in standard form, I subtract 0.5x from both sides. I subtract 13.5 from both sides. So I get minus 0.5x plus y minus 13.5 equals 0. Okay? So that's the standard form for the normal line going through the point 1, 14.